Every major technology company is spending billions of dollars building AI data centers. Microsoft, Amazon, Google, and Meta are building chips, securing electricity, and constructing buildings that consume as much power as an entire city. The International Energy Agency expects global data center electricity usage to roughly double by 2030. Wall Street is betting that the future of artificial intelligence is living inside these enormous buildings, but Apple might be quietly preparing to challenge the entire assumption. According to Bloomberg's Mark Gurman, Apple is engineering a future Mac chip design to support as much as 1.5 terabytes of unified memory. That sounds like another boring computer specification. It isn't, because a computer with that much memory could run some of the world's largest AI model without sending a single request to Microsoft, Amazon, or Google. No cloud subscription, no rented Nvidia GPU, no confidential company data leaving the building. Apple hasn't announced this machine. It's a supply chain report about a chip that may not arrive until 2028. But the direction it points to could threaten the most important assumption behind trillion-dollar AI infrastructure boom, that every powerful AI request must be processed in the cloud. To understand that, we need to answer three questions. Why would an ordinary desktop ever need 1.5 terabytes of memory? Why could memory matter more than raw processing power? And why would Apple quietly build a way to connect multiple Macs into something resembling a private AI supercomputer? By the end, you will see why answer could split the AI industry into two very different worlds. The 1.5 terabyte mystery. Let's start with numbers. Most laptops today ship with 16 to 64 gigabytes of memory. Even the most high-end professional workstations rarely exceed 512 gigabytes of memory. But Apple is reportedly engineering its future M7 Ultra chip to support 536 gigabytes, or you can say 1.5 terabytes of unified memory. And here the details tell you how serious Apple is. Apple is tearing up its own roadmap. According to the same reporting, Apple is skipping chips to get there. There may be no M6 Pro, no M6 Max, no M6 Ultra. Apple has reportedly cancelled almost an entire generation of high-end chips to rush an AI-focused M7 family into production, with M7 targeting AI performance in class of Nvidia Blackwell accelerators. Apple has skipped one chip before. It has never abandoned three at once. And there is a second signal. To build machines with this much memory, Apple has to buy enormous volume of DRAM, the same memory that Nvidia, the cloud giants, and every AI server manufacturer are fighting over right now. Memory prices have surged, supply is scarce. Whether Apple ever ships the full 1.5 terabyte will depend on winning that fight. In other words, Apple isn't just building a big computer, it's entering the same supply war as data center industry itself. But why? Why does a desktop need that much memory in the first place? The answer is already visible today. Apple's M3 Ultra Studio could be configured with 512 gigabytes of unified memory. Apple claimed that was enough to hold large language models with more than 600 billion parameters entirely in memory. Reviewers demonstrated a heavily compressed version of DeepSeek R1, a 671 billion parameters model running locally in that single machine. So why is it possible on a Mac when even expensive graphic cards can't do it? It's not because Apple's GPUs are more powerful than Nvidia's best data center chips. The answer is where memory sits. Apple's unified memory advantage. In traditional computers, the CPU uses system memory and the graphic cards has its own separate video memory. Data constantly shuffles between the two pools, and for large AI models, GPU memory capacity becomes a hard ceiling. Apple Silicon works differently. Its CPU, GPU, and neural accelerators share one giant pool of unified memory. The model doesn't need to be copied back and forth. Every part of the clip can reach all of it. And that lets Apple do something no consumer graphic card can: put hundreds of gigabytes of GPU accessible memory inside one compact box. And that matters because large language models are memory monsters. A compressed 4-bit version of a 600 billion parameter model needs roughly 300 gigabytes just to store its weight before context, working memory, or software overhead. So that's our first question answered. A desktop needs 1.5 terabytes of memory because that's what it takes to hold frontier scale AI model in one machine, which leads directly to the second question. If Apple chips can hold these models, can these actually run them usefully? To answer that, we have to separate two AI workloads that almost everyone confuses. Training is not inference. Training an AI model is like building an engine. It demands colossal dataset, trillions of calculations, and thousands of processors working in perfect coordination. This is Nvidia's fortress. Its GPUs, high-speed networking, and CUDA software ecosystem are built to spread enormous workloads across thousands of machines. A Mac Studio is never going to train the next GPT under someone's desk. But inference is different. Inference is what happens after the engine is built. Every time you ask an AI a question, summarize a document, or build a report, that's inference. Training builds the engine, inference drives the car. And here's the thing, most companies don't need to build engines. They need to drive running an existing model against their own private documents, workflows, and data. That's a completely different hardware problem. A business may not need 10,000 GPUs. It may need one capable model available all day, answering a few hundred employees quickly. And that's exactly the problem where memory matters more than raw compute. Because the bottleneck isn't calculation per second. It's whether the whole model fits. So second question answered. So now why would a company actually want AI to leave the cloud? Imagine a bank that wants AI assistant to analyze internal risk reports, a hospital that wants to summarize clinical records, a manufacturer that wants AI to study years of confidential production data. They can send all of that to a cloud computer. But that means four things. Sensitive data leaves the building. Every request demands an internet connection. Every response carries network latency. And every query adds to a bill that never stops. Local AI flips the equation. Buy the hardware once, run the model inside your own walls. The data never leaves. The system works even when connection doesn't. And once machine is running, the next 1,000 requests don't generate an API invoice. Microsoft itself has described this emerging pattern. Cloud training, edge inference. The powerful model is created in the cloud. The compressed version does the daily work locally. And Apple is assembling nearly every technical component required to power that shift. Nearly every component. But there's a layer that Apple does not build, and this is the layer that decides whether any of this works inside a real company. Here's a scenario. A company loads all of its internal documentation into a local AI model. On day one, the employee types a single question: what's my manager's salary? And the model answers because nobody told it not to. That one moment is the difference between an AI demo and AI product. A real enterprise system needs permission. Which employee can see which data? It needs audit logs, a record of who asked what. It needs monitoring, updates, and backups. The boring machinery that keeps system trustworthy at 3 a.m. None of this is existing, and all of it is mandatory. Apple has built impressive pieces of the puzzle. MLX, its open source framework for running and fine-tuning models on Apple Silicon. Core ML for deploying models inside apps. Foundation model framework that gives developers a common interface to Apple's on-device and cloud models. But Apple does not offer a complete enterprise control plane. One system for deploying, monitoring, and governance of local AI across entire company. And this gap is an open door for a whole new software market. And just as that market was starting to form, Apple shipped something that completely changed the scale of what local even means. In macOS 26.2, Apple enabled low latency communication between Macs over Thunderbolt 5. Apple has demonstrated AI inference running across 4 M3 Ultra Mac Studio connected as a single cluster. Read that again. Multiple Macs working together on the same giant model. That means local AI is no longer limited by one machine. A company could start with single Mac Studio, then plug in more when its models and workload grows. A modular private AI supercomputer, small enough to sit in an office, quiet enough to forget it's even there. That's the third question answered. Apple built Mac clusters because one desktop was never the end game. The end game is Office. rack. The reality check. Now, before anyone declares the data center death, one honest paragraph. 4 Mac are not Nvidia data centers. Nvidia still trains model faster, its deployment software is more mature, its networking is far more advanced, and for serving thousands of simultaneous users, its throughput isn't even close. Independent research finds Apple Silicon cost-effective for very large local models, while clearly trailing Nvidia for training and high-volume production serving. Even workloads differ. Recent benchmarks show strong large language model generation on Apple's chip, but Nvidia keeps a wide lead in image generation. So Apple's threat is not universal. It's concentrated precisely on one segment: private, predictable, and moderately scaled inference. The question is how big the segment becomes, and that tells us exactly who should be paying attention. Who wins, who loses? Apple is the obvious potential winner. A high memory Mac stops being a computer for a filmmaker and becomes an AI appliance for businesses. Hardware, Apple can sell without hosting anyone's data or competing with OpenAI. Local AI software companies win. Someone has to build the orchestration, security, and monitoring layer that Apple does not. That someone gets to sit between every enterprise and its model. Open model companies win. Businesses running AI locally need models they are legally and technically allowed to own. Nvidia is complicated. Apple could taper off local inference workloads that would have otherwise run on Nvidia hardware or Nvidia-powered cloud instances. But Nvidia Fortress, the frontier training, the massive scale serving, the developer ecosystem remains intact. And the cloud providers, they keep training frontier models, serving millions of simultaneous users, absorbing unpredictable demand spikes and renting capacity that companies need for a week, not decade. In fact, cheaper local AI could increase total cloud demand. When technology gets cheaper, people find far more use cases for it. The hardest new users still flow to the biggest machines, which bring us to the final twist. Because the strongest evidence for hybrid future comes from Apple itself. Apple doesn't believe that every AI request can run locally. Apple Intelligence is already a hybrid system. Small tasks run on your device, harder requests escalate to Apple's private cloud computer, large language models running on Apple's own server. In 2026, Apple extended the cloud infrastructure future. The same Mark Gurman reporting says Apple is developing server processors based on its Ultra chips for its own data center. So Apple is not killing AI data centers, it's doing something more sustainable. It is deciding which task deserves a data center and which does not. Today, most of the cloud industry assumes the default answer is the cloud. In Apple's vision of future, the devices tries first. The cloud becomes an escalation layer used only when the local system runs out of capability. If that architecture spreads across businesses, phones, and PCs, millions of routine AI requests simply stop traveling to centralized infrastructure. The data centers still survive, but the job description changes. Conclusion: the AI industry is building one of the largest infrastructure projects in human history and betting that the demand of centralized computing rises almost without limits. Maybe that bet pays off. Training keeps getting more expensive, usage keeps climbing, the energy forecast keeps doubling. But Apple's high memory machines reveal a second possible future. One where companies rent enormous clusters to train models, but own compact machines to run them. Where confidential data never leaves the office. Where cloud handles the hardest 10% of the request instead of all of them. Apple hasn't killed the data center. It's killing something more fundamental. The assumption that every AI calculation belongs inside one. The next AI war won't be simply Apple versus Nvidia or local versus cloud. It would be fought over a single question asked billion times a day. Where should this request run? On your device, inside your office, or instead a billion-dollar building? The company that controls that decision controls the next era of computing. So do you think companies will eventually run most AI locally, or cloud is impossible to replace? Tell me in the comment section below.